researchers have found something odd about Saturn's moon Titan. Roughly a billion miles from where you're sitting, lingering near Saturn's rocky rings, is a moon decorated with lush lakes and rivers. In its sky, there are clouds. On its land, organic molecules. Enveloping the orb is a dense atmosphere. It's one of the most Earth-like worlds ever discovered, and thus a prime place to hunt for alien life. We call it Titan. Now, a strange molecule has been found in its atmosphere, as this molecule has never been detected before in any other atmosphere. Yet this simple carbon-based formation could be a precursor to more complex compounds which may form or feed life forms on the moon. So let's talk about it. Welcome to Space World. In today's video, we are going to talk about something odd that has been discovered by researchers on Saturn's moon. So if you want to know more about it, then stay with us until the end of the video. Saturn's largest moon, Titan, is the only moon in our solar system that has a thick atmosphere. It's 4 times denser than Earth's, and now scientists have discovered a molecule in it that has never been found in any other atmosphere. It's called cyclopropionylidene, or C3H2, and it's made of carbon and hydrogen. This simple carbon-based molecule could be a precursor that contributes to chemical reactions that may create complex compounds, and those compounds could be the basis for potential life on Titan. The molecule was first noticed as researchers used the Atacama Large Millimeter Submillimeter Array of Telescopes in Chile. This radio telescope observatory captures a range of light signatures, which revealed the molecule among the unique chemistry of Titan's atmosphere. When I realized that I was looking at a cyclopropionylidene, my first thought was, well, this is really unexpected, said lead study author Connor Nixon, planetary scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, in a statement. Cyclopropionylidene has been detected elsewhere across our galaxy, mainly in molecular clouds of gas and dust, including the Taurus molecular cloud. This cloud, where stars are born, is located 400 light-years away in the Taurus constellation. In these clouds, temperatures are too cold for many chemical reactions to occur. But finding it in an atmosphere is a different story. This molecule can react easily when it collides with others to form something new. The researchers were likely able to spot it because they were looking through the upper layers of Titan's atmosphere, where the molecule has fewer gases it can interact with. Titan is unique in our solar system, Nixon said. It has proved to be a treasure trove of new molecules. Cyclopropionylidene is the second cyclic or closed-loop molecule detected at Titan. The first was benzene in 2003. Benzene is an organic chemical compound composed of carbon and hydrogen atoms. On Earth, benzene is found in crude oil, is used as an industrial chemical, and occurs naturally in the wake of volcanoes and forest fires. Cyclic molecules are crucial because they form the backbone rings for the nucleobases of DNA, according to NASA. The cyclic nature of them opens up this extra branch of chemistry that allows you to build these biologically important molecules, said study co-author Alexander Thelen, an astrobiologist at Goddard, in his statement. So when the researchers discovered cyclopropionylidene in Titan's atmosphere, they looked over data captured by NASA's Cassini mission. The spacecraft performed 127 close flybys of Titan between 2004 and 2017. Cassini's mass spectrometer detected a chemical signature of the same molecule, the researchers found. It is a very weird little molecule, so it's not going to be the kind you learn about in high school chemistry or even an undergraduate chemistry, said C. Malaska, who was not involved with this study, but he researches Titan. Every little piece and part you can discover can help you put together the huge puzzle of all the things going on there. And discovering cyclopropionylidene on Titan adds to the moon's intrigue. Now, in order to explore more about the moon, scientists have started comparing Titan to Earth because of its unique qualities. For years, scientists have been stumped by how these landscapes came to be, given their un-Earth-like composition. But now they've determined a very plausible theory. Because Titan's sediments are theorized to be made from solid organic compounds, they should be far more fragile than the silicate-based sediments found on Earth. Thus, nitrogen wind and liquid methane should wear Titan's sediments down to fine dust, which wouldn't be able to support such varied structures. A team led by Matthew Lepater, an assistant professor of geological sciences at Stanford University, has come up with a potential solution. A combination of sintering wind and seasonal change may be able to do the trick on Titan. The researchers studied a type of sediments called ooids, which can be found on Earth and which have a similar composition to Titan. Ooids can be found in tropical waters where they form very fine grains. These grains simultaneously accrete material via chemical precipitation and erode in the sea. As a result, they maintain a consistent size. The researchers think that something similar might be happening on Titan. We hypothesized that sintering, which involves neighboring grains fusing together into one piece, could counterbalance abrasion when winds transport the grains, Lepater said in a statement. The team then analyzed atmospheric data from Titan as recorded during the Cassini mission to determine how those sediments could have formed such vastly different geological features observed around the planet. The researchers discovered that winds were more common around the moon's equator, which created optimal conditions for the development of dunes. Elsewhere, however, the team suspected that lower winds allowed coarser grains to form and, in turn, more solid sedimentary rock to form. From there, wind could erode the harder rock down into finer sediments, just as what happens on Earth. Furthermore, because Titan is known to be the only celestial body in our solar system, besides Earth, to have a seasonal liquid transport cycle, Lepater's team then hypothesized that the movement of liquid methane likely contributes to erosion and sediment development too. We're showing that on Titan, just like on Earth, and what used to be the case on Mars, we have an active sedimentary cycle that can explain the latitudinal distribution of landscapes through episodic abrasion and sintering driven by Titan's seasons, Lepater said. It's pretty fascinating to think about how there's this alternative world so far out there where things are so different yet so similar. Adding to this, Titan has a dense atmosphere of nitrogen and methane, which gives it a fuzzy orange appearance. Its atmospheric pressure is 60% greater than Earth's, meaning it exerts the kind of pressure you feel at the bottom of a swimming pool, according to NASA. When sunlight touches Titan, those methane and nitrogen molecules in the atmosphere break apart. This creates intriguing, complex organic chemistry in Titan's atmosphere that has captivated scientists. Researchers are still sifting through Cassini data to try and determine what some of the chemical signatures were that the spacecraft detected. In addition, Titan also has Earth-like liquid bodies on its surface, but the rivers, lakes, and seas are made of liquid ethane and methane, which form clouds and cause liquid gas to rain from the sky. Researchers also believe Titan has an internal liquid water ocean. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.